and that'll be -2 less or equal.
Yep.
Then x less than or equal to 3.
You got it.
Okay.
All right, so the other problem here, number 8, is the outside case. So the outside case, or the non-inside, non-between case, is when you have a greater than or a greater than or equal to. And so the setup here is a little bit different. You take what you have and write it exactly as is without the inequality.
Mhm.
Without the absolute value. Keep the inequality, but write the absolute without the absolute value. Then you rewrite the left side. With the right, you flip the inequality and negate it.
Okay.
And there is now an or between them. Or is good. Or means one could be true, the other could be true, they could both be true. You solve by adding 3. X is greater than 8. Add 3. X is less than -2.
Mhm.
And we didn't do this before. We're gonna do it now on a number line. Let's just say, oh, it does say to graph. I'm sorry. We can go back and graph the other one. Let's just say that's -2 and that's 8. Open circle, less than -2 means to the left, greater than -8 means to the right.
Yeah.
So this is what I meant by outside. It's shaded outside.
Mhm.
Any questions on that?
Negative. That makes
Right.
sense.
Now in the previous one here, when we were supposed to graph this, we were now supposed to put a dot at all those points: -4, -3, -2, -1, 0, 1, and 2. Just a dot though.
Okay.
Now, if it were the real domain, you would shade everything from 2 to -4 to 2, between meaning inside or between two values.
Mhm.
All right, so let me have you try another one here. Let's go. Have you try one here. Let's go absolute value 3x plus 1 greater than or equal to 5. Could you try solving this for us?
Yes, sir. Okay.
Make
Okay.
sure you flip and negate the one on the right. That's the most important thing.
Yeah. So x is from 2 up to and including 4/3.
Okay, so x is greater than or equal to 4/3, or
Yeah.
what's
Yeah.
the other one become?
2.
Try again. Subtract 1 from both sides. 3x less than or equal to -6.
Oh, right. -2. Sorry.
Yes. Okay. So on a graph, what would that look like? Again, it would be -2, 4/3. 4/3 to the right, -2 to the left.
Mhm. Yeah. Okay. Gotcha.
All right. Number 9. a good one for us to look at next? That looks like a most recent lesson on logarithms.
Yes.
Okay. There are some properties, laws of logarithms. And very important to remember those. There's one here. It's the natural log of A plus the natural log of B. This becomes the natural log of A times B. And it says that a sum, which is the plus, becomes a product. So that this property applies to what's written here on the left.
Mhm.
So you write natural log x plus 3 times 4, just one natural logarithm. On the right, I'm just bringing it down.
Okay.
So you can think of this, all of this is A, this is B. The sum becomes a product.
Okay.
All right, so now from here, because the they both have ln, you can just set the part inside parentheses equal to each other. So if they're the same,
Mhm.
if they're the same, you just set it up. Say, okay, there it is.
Very well.
All right, and then solving for x here, you divide by 4. So x plus 3 equals 10. Subtract
X equals
3.
7.
Yeah, you got it. Now you are supposed to check your answer. I don't know how much that was emphasized.
Mhm.
The way you check is to put it back into the original. There's a little bit more to it. We'll just leave it at that for now. Looks like the other problem is also kind of the same, where it's not too bad, but there are some potential for extraneous solutions. So we'll address that when the time comes.
Mhm.
Okay, number 10, we'll look at another logarithm thing. There's another property of logarithms, which says log base b of x to the n becomes n log base b of x. And these properties are bidirectional. You can go either way, doesn't matter. What it's saying is if there's an exponent, you can bring it out in front. If there's a number out in front, it can become the exponent.
Mhm.
That applies here to this 3. This 3 becomes the exponent. So log 15 x cubed equals log 1527.
Mhm. Okay.
So now you set the parts inside parentheses because the logs are the same, equal to each other.
Yeah.
So x would equal 3.
Mhm. I see. Okay, gotcha, gotcha. All right. Sorry, just looking at him like, okay. So, all right. Hmm. Okay, here's something I'd like some help on. Question number 15.
Yeah, absolutely. Use the ln key. What does that like referring to something on your, are you supposed to use your calculator?
Yeah, I think that's what it's trying to say. Now, what I use is Desmos. They have it under the function part, I think.
Yeah, I mean, you don't really need that for this. I guess I'm not sure what they want you to express each number as a power. Okay. Um, so I think what they're trying to say here, and I don't actually think this is right. They're trying to tell you 0.00416 can be written as 4.16 times 10 to the minus 4 power,
Mhm.
and then 431 can be written as 4.31 times 10 to the power of 2. And then 0.0432 can be written as 4.32 times 10 to the minus 2. And so they want you to replace those in the thing up here. So we have 4.16 times 10 to the minus 4, 4.31 times 10 to the power of 2, and then over 4.32 times 10 to the minus 2 times 10 to the minus 17.
Mhm.
And then
Okay.
I think you're supposed to recognize that um, there's a way to sort of make these two really pretty much the same. 4.31, 4.32. Like, I don't know. I think you're supposed to, I don't know if you're supposed to like kind of estimate, but they're really close.
Mhm. Okay.
Because otherwise you can go right to a calculator to begin with, but we'll set that to the side. So now you got to deal with all these exponents. Let me maybe highlight them or something here. So you got 10 to the minus 4, 10 squared, 10 to the minus 2, 10 to the minus 17. So on the top, because you're multiplying, you add the exponents. Same thing on the bottom. So you have minus 2 over minus 19. Then you subtract them because of the top and bottom. Minus 2 minus a minus 19 becomes 17. So it looks like your answer is 4.16 times 10 to the minus, or sorry, 10 to the 17.
Mhm. Okay. Interesting that I want to cancel out the 4.31 and 4.32.
Well, I mean, you could basically go to the calculator. I mean, if you went to the calculator from the beginning, your answer would be really close to this anyway,
Yeah, gotcha. Okay.
but not sure. This is maybe one to ask about.
Mm-hmm. Gotcha. All right.
Okay, so 118, 118. Is there any questions from 117 in your lesson here?
Um,
Doesn't look like it, as far as I can tell.
oh, question number 6 with the exponential questions.
Okay, let's take a look. The number of amoeba increased exponentially. At first, there were 40. 3 hours later, there were 640. How many amoeba would there be at the end of 20 hours? All right. First thing, I guess, is to use some sort of exponential equation. At is kind of the one that comes to mind here. G is the initial amount. So the initial amount in your problem is 40. And we know that later on, when T equals 3, that there were 640.
Mm-hmm.
So this is enough to sort of get going here on this. You can say that A equals 40 A to the T. And then you've got 640 equals 40 A to the power of 3. So we can solve for A, divide both sides by 40. So looks like that's 16 equals A cubed. And that means that A is the cube root of 16, which does
Mhm.
not work out nicely, but looks like it
Whatever.
could. This is one of those again where it's kind of like, well, how many decimal places should you round to? I don't know. This is either you want to have things work out nice and avoid the situation, or you're gonna want to go to like 4 to 6 decimal places.
Yeah, I'm just looking right here. It says 2.5198421. So
I think I heard 2.5198. So that goes back
yeah.
in, that goes back into here for a, little a. A equals 42.5198 to the power of t. And then we're interested in finding out, well, how many would there be at the end of 20 hours? So t equals 20, it looks like. And there will be a
Mhm.
lot there
Yeah.
if this holds.
Okay. Look at the next page.
So I got,
Okay. Okay, good.
are there any other questions from exponentials?
I don't think so. Although question number 18 looks like that'll be, helpful.
Sure. This is something you would do in chemistry. A lot of students have been doing this lately.
Yep.
There are like 4 things of interest. There's the pH, and there's the pOH, and then there's the concentration of H plus and the concentration of OH minus. Like there's 4 things you might be asked to calculate.
Mhm.
In this problem, they tell you that the concentration of H plus is 9.52 times 10 to the minus 12.
Mhm.
And so the pH in this problem is minus the log of 9.52 times 10 to the minus 12.
Okay. Let's see. Would you like me to calculate that?
Yeah, if you don't mind. It should
All
be a
right.
number between 1 to 14.
11.02.
Okay. So the pH and the pOH, the sum of those, they add to 14. So you can pretty quickly find that the pOH is 2.98 by subtracting from 14.
Okay.
And then to find the OH, it's 10 to the minus T. Well, sorry, I guess you guys aren't doing it that way. Oh, sorry, pOH. Oh, you don't need that. I'm sorry. You just need the pH. I'm going way too far. Sorry.
Mhm.
I thought we were doing a chemistry lesson.
Ah,
Nope. All right. Is that okay?
yes. Yep. That's good.
I mean, I'm happy to pick some problems as well, whenever you're
Yeah.
ready.
Yeah, sure.
I
Good.
know last time we did some
Mhm.
like 17 that I was going to suggest you graph on Desmos and see if you have any
Yeah.
questions about that. It's kind of multiple choice. You just graph it and which one is correct.
Yeah, sure. Go and do that. Okay. Also, family just came back, so they'll probably come in and give me some food, but
Okay.
I shan't be too loud while reading. This might interrupt for a couple seconds. Okay, so Bravo.
Yes, correct. So if you want to know how I tell, I look at the line and I know it's below the line. I'm
Mm,
sorry. No, I'm sorry. That's the wrong thing. The line is this one. This is the line. It's above the line. So I draw little arrows there. And then I know that for the parabola, it's below it. And the only one that's where the overlap is right in there, which is
Yep.
essentially what you're doing with the software computer, but it's shading it for you. Okay, 23 is one we've done a number of times. You have to combine two of the three equations in a certain way. It will eliminate either all of the variables, one of the variables to get down to two. This one also does kind of work out nicely, meaning you can eliminate two of the variables if you're careful with how you combine the
mhm,
equations.
Okay.
If you could do that
So,
for us, please.
yep. Okay, so we're trying to eliminate some variables here. Just copy it down. Okay.
What two equations did you end up combining?
Uh, B and C, so x equals 1.
Okay.
And then let's
I also
see.
like to point out if you combine 1 and 2 or A and B, you eliminate Y,
Mhm,
which might be your best approach for getting
Yeah.
V solved for.
Ready. X equals 3.
You just said X equals 1. It can't
Or
change.
sorry,
Maybe
I meant Z. Sorry.
okay, good. So
Yeah.
equals 3. All right.
And then let's see. Z equals on. Oh wait, sorry. Z equals 9.
You just found Z.
Y.
Maybe you meant
Sorry. Let me confirm that though. Oh wait, sorry, no. Z equals -3. Or Y. Silly me. Let me, sorry, my mind's all jumbled up. Y equals 9.
Y equals 9 and Z is -3.
Yeah, or
Okay.
3, sorry.
Yeah.
Um,
What?
I think actually Z is just 3. Yeah.
You want to look at it one more time because I mean,
Okay, you got -3?
no, I'm gonna wait till you're done and then I'm gonna check them. So
Okay.
it's
So let me look here.
I'd recommend combining the first two, solving
Mhm.
for Z, and then using any of them to find Y.
Okay. Oops. Z equals negative 12.
Okay,
What I got?
keep going. What does y become?
Okay. Y equals 4.
Now to check, this is the critical moment here, is 2 times 1 minus 4 minus a minus 12, 8. So 2 minus 4 is minus 2. Minus a minus 12 is not 8. So we got some problems here.
Hmm.
All right, let's take a look here. So 5 times x, 5 times 1, 5, minus 2z equals 17. Subtract 5 from both sides, minus 2z equals 12. There's your issue. Z is minus 6. So
Okay.
could you try solving for y now that we have those, please?
Yeah. Y equals 0.
Okay. So now let's try it in the second equation. Is 3 times 1 plus 0 minus a minus 6, 9, and that does work. Is 6
Okay.
times 1, 6 minus a minus 0 plus negative 6, 0? Yes, it does work. There's
All
no
right.
reason to ever get these wrong. Meaning, because you can check them, you should be able to rework it until you get the right answer,
Yeah.
which you may not like, but you know, that's what we got here.
Yeah.
So do you want me to pick some more problems? Do you see one that you've been struggling with?
Um. You can just go and pick something.
Okay, 11's looking pretty good. We did these up, I'll say a month ago. The distance between. Find a number that is 4/5 of the way from 6 over 1/10, 6 and 1/10 to 12 and 3/20.
All right. So,
How do we proceed?
right. So if I remember correctly, we're going to subtract 6 and 1/10 from 12 and 3/20. Multiply that
Right.
by 4/5 and then add that to 6 and 1/10.
There you go. You got it. Now, not all that's left is to do that. Now, I mean, you could enter this into something like a scientific calculator, and it'll give you the answer, but you can work it out
Yeah.
in pieces if you'd like.
All righty. Um, 547 divided by 50.
Okay. Write that down here. I'm not quite caught up. Could be right. Let's see here. X times. Oops. You're seeing my formulas. X. Yep, we are in the same answer. Very good. Okay. Those aren't too bad anymore. I thought there was another one of those down 27, really similar. Might as well do that since we've
All right.
already got that kind of worked out here. I'll do it as well. Um, same formula, same everything.
Mhm. All right. So 1/5, all in parentheses, 5 and 2/5 minus 3 and 1/3, plus 3 and 1/5. Sorry, 3 and 1/3.
All right, I agree.
All right. So let me get to calculating. What my system say?
Some people say do the math.
Oh,
I mean, go to the calculator, but we've done the
yeah.
math actually. The everything else from here is just how you want to present your answer.
Yeah. Okay. 281 divided by 75.
Okay, you got those down for sure. Let's see, what other problems have we done? There was a 25 completing the square type problem for graphing. That might
Mhm.
be good to look at next here. All right, complete the squares and aid in graphing. We've talked about this a few times. It's always good to set it equal to 0. Let's just rewrite it as is, but equal to 0. I'm just gonna put it over here a little bit. Move the constant over,
Mhm.
and you got to fill in. You got to fill in this space here. I like to factor out the negative when it's in front. It's not necessary, but I think it really helps with working out the problem. So completing the square is the step here where you divide by 2. And then you square to go back, so it becomes +1. And this is now where that fact that you factored out a negative really matters. The fact that the negative is pulled out here, really it's distributed into each of these. That means the red box is -1, not +1, to be consistent.
Yeah.
And that's where it's a little bit disruptive to what you're normally used to. You're used to, oh, it's always positive. Well, sometimes, then you bring down the negative there. Now, if you're solving this, you would do something different. It wants you to graph, but basically there's two forks in the road here. For solving, you do one set of steps. For graphing, you do another. Since for graphing, you're going to add 2 to both sides. And you get back to your
Mhm.
result here. Now, what is the vertex of this? We haven't talked about this in a while. What's the vertex?
Um, it's going to point downwards.
Vertex. Vertex is that peak or it's the bottom point or the top point. And it comes
Right.
from this
2.
help here. It's 2 numbers.
Okay.
It's HK. It's your vertex.
That's right. Okay. So that's going to be -1 +2.
That tells you
Yeah.
kind of where you're starting. You're like, okay, it's right there, and it goes down. You know, not to sure that's to scale, but
Yeah. Close enough.
yes.
All right. What next would you like to go over?
I thought 34 was good. We did that couple of these. Since there's only one, I guess maybe I'll see if you can do it on your own before I jump in, try to work it out.
Okay. So whoops. Okay. Okay, so 99 and okay, so 99n equals 1.3013. Which
Okay.
equals 1183 divided by 90,000.
Okay, what you're, yeah, just give me your final answer, because I don't want to tell you're wrong, or it sounds like you're doing it a different way than I've shown you, and that's fine. I just don't want to hear something that,
1183 divided by 90,000.
okay. Have you tried that in a calculator?
Yeah. Which equals 0.0131, and then auxiliary points after that.
So that, I mean, if you only cared about the first 4 decimal places or 3, I guess that would be okay. There is
Yeah.
a different way to do this. Okay. That maybe that worked in some other world, where you don't care about the repeating part. So the repeating part's really important. Like you want something that literally looks like 1 3 1 3 1 3 forever.
Hmm.
So to get that, you have to rewrite this number as 0.13 repeating times 10 to the minus 1.
Okay.
And if that's not clear, it's how you move the decimal to get it in front here.
Move it 2 places to the right.
Yes. So this is 1/10 here. 0.13 repeating is 13/99. You put each of the repeating digits over a 9,
Hmm.
and then you just multiply them together. So it's 13/990.
Okay.
And go ahead and try that in a calculator. See if that gives you what you want.
Yes, it does.
Okay. Let me have you try another one here, because I think that was all that great. Let's go 0.00278 repeating.
All right. So I'm gonna multiply it by 1 to the negative, sorry, 10 to the negative 1 power. Um, with that, I get 0.00278.
Yeah, I want the fraction.
Okay, 139 divided by 500,000.
139 is right.
Oh, wait. Huh.
So
Okay.
it's 0.278 times 10 to the minus 2. That's 1/100.
Oh, okay. I did to the negative 1 power. I see.
Okay,
Yeah.
that's the difference. All right, good. Okay, what anything else? There's not really anything else here that I remember you being like, oh yeah, or even we've covered in a previous lesson that's been really difficult. So you want to pick something, or
Okay. Maybe like,
actually 19 was related to 18, now that I see that, but
okay. Whatever you think.
okay, let's do 19 real quick. All right, find the concentration of hydrogen ions if the pH is 2.23. So pH is 2.23. The concentration of hydrogen ions is 10 to the minus pH, 10 to the minus 2.23.
Mhm.
And so after you calculate that, I'd like to kind of just summarize the formulas.
Okay. Let's see. 0.0058 or 9, sorry.
Really? That's not, thought it's not soon. So I was expecting something in scientific notation. So, yeah, so this would be better written as 5.89 times 10 to the minus 3.
Okay.
So there's two formulas. There's if you're given the pH or the pOH, okay, to find the concentration of H plus, it's 10 to the minus pH. If you're trying to find the concentration of OH minus, it's 10 to the minus pOH. That's what we did in this problem.
Okay.
And then if they give you the concentration of H plus ions, to find the pH, you have to do minus the log of the concentration of H plus. And if they give you the concentration of OH minus, to find the pOH, you do minus the log of OH minus. There's two directions that you could be given to go. And I believe the previous problem 18 was like this one down at the bottom, and 19 was this one here.
Very well. Anything else do you feel we need to cover?
We did 26 in a previous lesson, so maybe take a look at your notes. I don't know how easy it would be to find, but
Maybe 5.
5, yeah.
Yeah.
Ah, yes.
Yeah.
We did this in another lesson. Okay. All right, I'll just try to set it up here. Pretty short on time for doing it all. Sum of a the sum of the digits of a 2-digit counting number is 5. So I'm going to use x, y as that number. So we know that x plus y is 5. If the digits were reversed, y and then x, the new number would be 27 less than the original number. Okay. So the new number, and this is where it's a little bit awkward. It's x plus 10y. You get the new number. You can't just merge them together. Would be 27 less. Okay, so this number is 27 less than the original number. Is 27 less than the original number. The original number is y plus 10x.
Okay.
So you have to be able to set up the equations. You're always going to use substitution to solve these. So you're gonna solve this first one for x or y, plop it in, and
Okay.
get the other number.
All right. So you want me to do that right now?
We don't have time for
All right.
that. I can quickly solve this though, and with another
Okay.
piece of thing I use to give you the answers. But yeah, you can try working it out. Maybe you can solve it really fast.
Okay.
I just don't want to.
Yeah. Go over time. Yeah. Well, I probably wouldn't be able to solve in time. So. And hammer away.
That's why computers. Imagine
Yeah,
if we had
are
to.
handy.
Yeah, they're pretty handy. Okay, we're gonna stop here.
All right.
Do you